So we'll continue our discussion on fourth method, that is American Standard Association method. So we will be mainly concentrating on the theory exam, okay. So how to get more marks and how to pass, okay. So I'll try to discuss accordingly here. American Standard Association voltage regulation method here. So what I can say that this is the most accurate method. This is the most accurate method, okay. So if you can recall what we discussed, that EMF method. So percentage voltage regulation, we are getting more than the actual. Yes or no? We are getting the more than the actual. MMM method, I am getting percentage voltage regulation less than the actual, okay. ZPF method, okay. ZPF method, so it's nearly what I can say that it is nearly equal, but slightly less than the actual, okay. So the fourth one is American Standard Association method, which is the most accurate method. What I can say that why it is most accurate, because even here, so I'm including the unsaturated excitation. Unsaturated excitation is included. Unsaturated excitation is included, okay. Unsaturated excitation is included. As I'm including the unsaturated excitation, that's why we are getting the what is the actual value. We are getting the estimated value also nearly the same as that of the actual value. So in order to get the actual testing, what we are doing here, we are supposed to apply the full loads, and we have to apply the no loads and get the no load and full load values and find out the percentage regulation. That is the normal testing method. But instead of doing that, so instead of wasting a huge amount of power, what I am doing here, I am going with these methods. So that what happens here, we can able to estimate for a large rating machine, we can able to estimate what's the percentage voltage regulation to assess the machine performance correctly here. Out of that, we have 4 methods. So each method has one method is giving EMF method is giving more than percentage auto regulation, MMF less than that, ZPF is nearly equal, but we are not considering the unsaturated excitation. Here in the ASI method, we are considering the unsaturated excitation here. So the advantage is nothing but it's nearly 60% same as ZPF method. This method is 60% same as the ZPF method. Let's try to discuss. Let's try to draw the graph. Okay. So for this, what we require here, we require OCC characteristics and ZPF zero power factor characteristics. OCC characteristics required, and other one is zero power factor characteristics also required. So how we draw OCC, we already experienced here. This is OCC characteristics, and this one is ZPFC characteristics here. This is OCC characteristics as well as this is ZPFC characteristics. Once OCC and ZPFC characteristics are drawn here, next what should I do here? I need to draw a dotted. I need to find out the rated voltage. And draw the this one is phase voltage or line voltage? Respond. This one is phase voltage. We have to convert all the parameters into phase, and then we have to substitute here. So draw a dotted line onto where? ZPFC point here. Give the notation as, let's assume that this point is O, this point is A, and this point is B here. Okay. Now from this, so 60% same as that of the ZPF only. So whatever the OA length is there, okay, whatever the OA length that is there here, same length I need to draw. What are the OA length? Same length I need to draw from point B, and then draw a line to the left side. Draw a point towards the left side. Okay. So what is this length here? This length, give the notation as C here. So I can conclude that BC length is OA length. So by learning this ZPF method, we can even majority 60% we can able to solve. Okay, BC length is equal to the OA length here. And next, what we are supposed to do? Again, draw a tangent to OCC. Draw a tangent to OCC. So draw a tangent to OCC. This I am calling it as air gap length here. Now what should I do here? From point C, draw a line from point C draw a line such that it should be parallel to air gap line. It should be parallel to air gap line. Okay. Okay, it should be parallel to air gap line. Now give the notation as some point D here. Okay, I'm not bothered in the notations here. So next from this, what should I do next? Okay, from this points, draw a perpendicular line. Okay, and join these two here. Give the notation as H here. Okay, this forms a right angle Portier triangle here. The red color which I'm representing here, this is a right angle Portier triangle. Okay, right angle Portier triangle here. Now here, what are this BH represents here? BH represents IFA and CH represents IFL. BH represents IFA and CH represents IFL. So I'll try to write here also. BH is IFA length. So field current required to generate the armature reaction. Next, IFL is nothing but field current required to generate leakage reactance, which we already discussed. I'm sorry. Okay. So here, for excitation, we require some current here. Okay. This is the corresponding field current which is required to generate armature reaction, and IFL is the current which is field current which is required to generate leakage reactance here. And what about this DH here? This is IAXL drop here. This is IAXL drop here. DH is IA into XL drop here. Now here we know up to now this one is same as that of the ZPF method. From now onwards, I'll try to make small changes here. Okay. Now here this point. Okay. From the whatever the dotted line is there. Remember here. From now there is a variation here. Whatever the dotted line is there here. Okay. From this point, give the notation as some intersection point, some H or whatever it is, some F. This length is nothing but I am considering it as IFR. Previously, how IFR is measured here? I have used the EMF method. From that, I have used the formula E naught equal to under root of V phase sin phi, V phase cos phi, IARA whole square plus V phase sin phi, IAXL whole square. From the corresponding E naughts, I have measured the IFR. Now for this ASA method, from the dotted rated phase voltage here, wherever the air gap line intersects here, draw that, measure that length, and that length is considered as IFR. So we got IFR, we got IFL, we got IFA here. Okay, this. Sorry here. Okay. So what I will try to do here, I will try to do the phasor sum of these two here. If this is the IFR length, okay. So I will try to apply the MMF method now. I will try to apply the MMF method. So if this is the IFR here, and I will try to take the combination of IFA plus IFL length, whatever the length that is covered here, the length in terms of field current here, this BC length is total is IFA plus IFL. Okay, total length plus IFR. I am not adding these two directly here. These two are two different vectors here, so that what actually happens here, the phasor sum of these two will be, the phasor sum of these two will be unsaturated excitation. Unsaturated excitation. Okay, I told you just one thing. Okay, one thing small round. Here it is. Saturated excitation is included here. What is the advantage here? I am including the saturated, not unsaturated. Just slightly make the changes here. Okay. So saturated excitation is included here. So what is the phasor sum of these two? IFR. How I am finding IFR here? Whatever the dotted line is there, whatever the dotted phase voltage is there, I am measuring the IFR here. The IFR phasor is added with IFA plus IFL. IFR phasor is added with IFA plus IFL. These two combines the unsaturated excitation. This two combines the unsaturated excitation. Next, I hope is this clear or not? So what is the corresponding formula here? So here IF unsaturated. I am writing here the resultant of this one is IF unsaturated. I am writing this term as IF unsaturated. What is the corresponding formula here? IFR plus IFA plus IFL whole square. I'm sorry, I will just. Okay, IFR whole square plus IFA plus IFL whole square plus 2 into IFR plus IFA plus IFL into cos of 180 minus 90 plus or minus 5. Okay, this is the MMM method formula. Same, we have used IFA square plus IFL square plus 2 into IFA into IFL into cos of 180 minus 90 plus or minus 5. Instead of IFA, I am replacing the terms here. One phasor is IFR, other phasor is IFA plus IFL. So the phasor, the resultant is this one. Okay, this is the 5 here. The resultant is IFR whole square plus IFA plus IFL whole square plus 2 into IFR into IFA plus IFL into cos of 180 minus 90 plus or minus 5. Where plus indicates lagging load, minus indicates leading load. Plus indicates lagging load and minus indicates leading load here. Okay, once this is done, we got IF unsaturated. Okay, now if I take the corresponding IFR and onto the graph and try to measure the E naught here, again I am not including the saturation effect here. So again the value will not be accurate. The percentage voltage regulation or E naught will be not accurate here. It's slightly less than the actual value here. To get the saturated impedance here, what I am doing here. Okay, so what we did so far here. So for the ASM method, it is similar to that of the ZPF method. We have constructed the Portier triangle method, and from this, from the y-axis to the air gap line, the intersection point, I have considered this as IFR, and I have used the phasor diagram to calculate. I have included this MF method to calculate IFR, phasor sum of IFR plus IFA plus IFL, and I got that IF unsaturated. Now what I will try to do here, I will try to include the EMF method here. I will try to include the EMF method. Okay. So in the EMF method, what I am supposed to do here, I need to calculate ER. Okay, I need to calculate ER here. What is the phasor? What is the formula for ER here? E equal to V plus IARA plus IA into XL. If I want to convert into the phasor diagram here, then ER. This is not the final value, intermediate value here. So that the formula will be V phase. Okay, V phase cos phi plus IARA whole square plus V phase sin phi plus or minus IA into XL whole square. Where can I get this data here? IA into XL. Where can I get this IA XL length here? From this like DH length here. From the DH length I can able to get this length here. Just make the changes here. Okay. So from this, the ER length I can able to calculate by using the EMF method. V phase cos phi IARA plus plus IRA whole square plus V phase sin phi IE plus or minus IA XL, where plus stands for lagging and minus stands for leading here. Now whatever the ER that I am getting here, let's assume that whatever the ER length, let's assume that I am getting the ER length here. Okay, so draw a dotted line onto OCC. Draw a dotted line onto OCC. Now this length, draw a dotted line onto OCC. Now give the notation as some M point here. This length is the M. This length. Give the notation as this M and this notation as some Y. This one is H. We have drawn up to H here. Let's say that I J. This one is I. This one is J here. These 2 points. This length I J length. What I can consider here I J length as IF saturated. This is the exact method. How to find out this IF saturated here? So Draw how I am calculating ER here from the graph. Use the EMF method. Use the formula here. That is same. What are the method? What are the formula that I am using in EMF method? That is under root of V phase cos phi plus or plus IA RA whole square plus V phase sin phi plus or minus IA XL. Represent this ER in the graph from the draw a dotted line onto OCC. Now here till now for this I have calculated unsaturated excitation, IF unsaturated. Now in ASA method even I am considering the saturated excitation. For that saturated excitation, how can I able to represent the saturated excitation? From graph I am measuring IJ value here. From graph I am measuring IJ. This is saturated excitation. Measure the corresponding length, not in centimeters, measure in terms of amperes. Measure the corresponding length, and next what should I do now here? After this, once it is done here, add this one as this one what I represent here. This is IJ length. This is what is this length? IF saturated. So what is the final current that I am getting here? IF total equal to IF unsaturated plus IF saturated. IF unsaturated plus IF saturated here. So this is what we need to remember here. This is arithmetic sum. This is arithmetic sum here. Directly I can add here. Okay. Directly I can add here the length of this MD length. This length can be considered as IF saturated. So what I am including in detail, I am including IFR, I am including IFA, IFL. So I am also including IF saturated. So all the corresponding terms, IFA corresponds to what? Armature reaction. The field current required to generate armature reaction. IFL length is the field current required to generate leakage reactance. Okay. And combining with these two will get unsaturated excitation, and IF saturated is even the saturation is also considered. When everything is considered, we can able to get the IFT here. When IFT we got here, what I am supposed to do here? Whatever the corresponding IFT that I got here, I need to represent this. I need to represent this IFT here. I will change one more color here. I need to represent this as IFT here on the x-axis. From now, what should I here? Draw a dotted line. Draw a dotted line onto where? OCC here. Once I have measured this IFT, IFT is the final field current here to get the E0 here. From the OCC, draw a dotted line onto y-axis, and this point will be E0 here. Once we get E0 here, E0 we can able to measure the percentage voltage regulation, that is equal to E0 phase minus V phase by V phase into 100. This is how we can able to measure the percentage voltage regulation by using the ASA method. So till constructing the Portia triangle, everything is same as that of the ZPF method. And after this, I need to whatever the length that is there from the y-axis to this length. This length is considered as IFR. And next, measure ER by using the EMF method. What is the EMF method formula here? So simply representing this all these are all phasors here, and converting this into the EMF formula here, that is ER equal to this formula. And from the corresponding ER, measure this length here, IJ length. This length is considered as saturated excitation. Now measure the unsaturated excitation and add the saturated excitation. Directly we can able to get the total IFT here. For the corresponding IFT, locate the IFT in x-axis and represent on OCC and find out the E0 here. This is how we can, and once we got the E0 here, we can able to measure the percentage voltage regulation. This is how we can able to measure the percentage voltage regulation by using the ASA method here. We can able to, if I want to compare, we can able to get the values as EMF method. Okay, if I want to consider these four voltage regulations in different methods here, EMF method, next ASA method, next ZPF method, and next one is MMM method. This is the order of percentage voltage regulation calculated. Okay, so as we already discussed several times here, EMF method, pessimistic method, ASA method, most accurate method, ZPF method, second preferred method, MMM method is optimistic method, as we are getting the less than the percentage actual value here. These are the sequence of to measure the percentage voltage regulation rather than directly applying the load here. So we are estimating the percentage voltage regulation by using the following 4 methods here. So out of this, you can expect numerical problems for EMF, ZPF, MMF here. There are less chances in asking the numerical questions, as this is the most toughest one. Okay, and whereas you can expect theory steps of procedure for all the 4 types here. This is all about the important questions of the percentage voltage regulation methods.